Okay, so here we go. We're going to learn about something called the Hilbert curve.
Yeah.
And the Hilbert curve is a fractal that you make in a sequence of moves, okay?
Yeah.
So we're going to start with this picture. It just looks like an upside down U.
Yep. So like an N.
Yeah, kind of like an N. And that's in a big square, right?
Yeah. Yeah.
And on every step, what we're going to do is we're going to take copies of whatever we have in the big square and we're going to put them into these quadrants.
Yep.
And the rules are, in the top left, we're going to have the same shape.
And
in the top right, we're going to reverse the shape, but our shape is symmetric.
Yeah.
So it's going to look the same. So we're going to have the same shape here, same shape here. On the bottom left, we're going to rotate it clockwise. Can you show me which way rotating this clockwise will be?
It'll be like that.
It's going to be like that. So we're going to have this sort of N shape down here, like that.
Yep.
And on the bottom right, we're going to rotate 90 degrees counterclockwise.
Cool.
That way. And you guys did a good job making one of these, right? So
Yep.
which one, where's the next step?
The next is some stuff.
Okay. So here we go. So we said in the top left, hopefully this shows up okay on camera.
Top left.
Top left, we have the same shape.
Top
See it?
right
Top right.
is reverse.
It's reverse. Rotate, rotate, and then we just connect
Connect the points.
the two pieces. So we get a curve that, so we start like this, and then we go, okay? And now we repeat the process. We're going to have this shape here go into the top corner.
Yep.
It's going to go into the top right corner reversed. It's going to be turned clockwise and turned counterclockwise.
Cool.
And that looks like that.
Whoa.
Whoa. And this curve was invented by a guy named David Hilbert.
Yep.
And if you keep doing this, you fill up the whole square just with a line.
Whoa.
And now we were able to 3D print an example that's two later than this. So this would be number 5. I don't know how well this is going to show up on camera. So let me see if I can kind of bring it closer to the camera. Might be hard to see, who knows. But you can see from this that it really starts, even at step 5, it's starting to fill up. And Hilbert proved that eventually this fills up the whole square after an infinite number of steps.
Cool.
Yeah, isn't that amazing?
Yeah.
So this curve is called the Hilbert curve.
Yep.
So what did we learn? We learned a line segment.
It can fill up the whole plane.
It could end up filling up the whole plane because we can make this square as big as we want to.
Yeah.
Or, here's a different idea. You see how it can fill up a sort of a finite square?
Yeah.
Imagine folding that square up and making a sphere out of it.
Whoa.
And then the sphere had the same number as the whole plane, right?
Yeah.
So Banach-Tarski that we started with, where one orange can suddenly turn into 2 oranges.
Yeah.
It seems crazy, right?
Yeah.
Like, actually it seems completely crazy.
Yeah.
But what I just showed you, which is easier to understand, is how just one line segment has the same number of points as the whole plane.
Whoa.
And finally, we also saw in the 3D printing blog a way to make cubes.
Cubes, yeah.
Hilbert cubes. And so we made that you can imagine, instead of just filling up the whole plane, you can fill up
Like.
space,
Yeah.
like 3-dimensional space with just a line.
Wow.
Pretty amazing. Do you remember, where's the smaller one we made? Is that line around? Oh, it's right next to the computer. So you can fill up not just a plane, but you can fill up cubes.
Cubes, cool.
In other words, 3-dimensional space has the same number of points as just a line segment.
Whoa. What?
Pretty amazing, right?
Whoa. Yeah.
All right. Good job, guys. Good job.